I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today, our students of second year BME are going to give a demo on design thinking approach for virtual instrumentation. And we know that it is very difficult to acquire physiological signals from our measurement systems. So we need a perfect solution for that. So today we are going to have a demo for waveform generation and array, shift register and string using LabVIEW. Shall we start?
In this design thinking, we will explore the empathy, define and ideate of acquiring physiological signals. So the empathy part is that we have to acquire physiological signals with high precision and accuracy for further use. And the define is that we have problems with acquiring the physiological signals with accuracy and precision, which can lead to dangerous causes of further use. And to ideate, we are using this graphical programming method called as LabVIEW to acquire the signals. This LabVIEW technology is used in automation and to deal with real life settlement problems of data acquisition.
Okay, in this experiment we are going to see about waveform generation using a formula node and expression node. Here we are going to see about nearly 5 steps. Our first step is placing an amplitude and frequency control in a frontal panel, and we are add a waveform chart and waveform graph to show the waveform frequencies. And in step 2 we are opening a block diagram panel. In that we are introducing a for loop for a continuous wave generation. In that we are placing in a formula node which is coded within a formula sine wave equation which is with amplitude, time and frequency. And then we are then we are using expression node in a formula node to express the final output. The final output will be given by Raghunath.
Hello everyone, myself Raghunath. I am here to explain the waveform generation using the NI LabVIEW. In this, in the block diagram panel, we are first creating the for loop. The big rectangle shown in this was the for loop. Inside the for loop, we are creating a formula node. The n terminal of the for loop is connected to the constant 90, which means the for loop is executed 90 times, and the iteration for 0 to 89 is provided as the output. Then the formula node, the x is the x which each time it create the value of x and compute with sin x and give the output as y. The y terminal is connected to the waveform chart and a waveform graph, which gives the output as waveform chart and waveform graph. The waveform chart is placed inside the for loop because it gives the output while the program was executing, and the waveform graph was given outside the for loop, which gives the output after the whole 0 to 89 times it is iterated. The iteration block is connected into 0.05, which is the value to get the clear and easy sine graph. Let us see the output of this program.
It's the final output of waveform generation using a formula node and expression node.
Now we are going to see the shift register using array and string function. First on frontal panel, we should pick the control system and give the array measure to insert an array. After inserting an array, the array will be appeared on the block diagram block. We should extend the array block as 5 times with the numeric constants. Once the array is connected, we should on using the frontal panel block diagram panel. Here also there will be array. That we have to add a array maximum minimum value to the front block diagram. Once it is added, then we should create an indicator by right clicking the maximum minimum value and create indicator. Once the indicator is created, 4 indicator will be available: max value, max index, minimum value, minimum index. Once we apply value to the numeric constants in the array as given some values, 2, 3, 4. After giving some inputs in the array, the construction should be run. Here the minimum maximum value is 7 and maximum index is 8. Minimum value is 0 and minimum index is 0.
So I am here to explain what each of these components are used for. So the first thing is array. So array, we know that it is an component or it is an part here to store the multiple numbers at a stretch, not on creating an each one by one and variable and all those. So it is an element that is used to store all the various elements or numbers or variables, any of the thing. And as Balaji said, we used here 4 numerical indicators. So these indicators, 2 of them shows their maximum and minimum value respectively, and another 2 shows their maximum index value and minimum index value. So here index value is signifies the position of the element that is acquired in the array. That is what the index value is meant here. And there are 4 indicators, and at last we will be getting output as which number will get a minimum or which number will get maximum and their respective index values. So then we used here, as I said, an array with the maximum and minimum value to differentiate it. We need that element to differentiate which is having the maximum and minimum value. Here we will implement all those numbers, and in that input we will give what is the minimum and maximum value. We will get as an output what is the minimum value in the respective array and maximum value, and he will be showing the output how it is going.
In conclusion, we learned how to use basic and advanced programming tools in LabVIEW. We learned how to create sub-VIs and how to use loops and control structures to control a program. In addition, we also learned how to use shift registers to store data and arrays to handle multiple values. In conclusion, we also gained knowledge on how to use these programming tools and solve real-world problems. Thank you.
Thank you.